Have you seen the Mythbusters TV show? It's my favorite show. The serious and skillful Jamie Heineman and his comic co-host Adam Savage test the reality of 3 myths or urban legends in each hourly show. I love the show so much that I made my own episode. Let's watch it. The myth I'm testing today says that you should not mix the brands of oil in your car's engine. Different brands of oil have different chemical additives. According to the myth, these chemicals can interact, causing the oil to lose its lubricating properties or even form lumps that will ruin your car's engine. I went to my auto parts store and I found 6 brands of motor oil. My samples range from this expensive synthetic oil to this premium, which means cheap, motor oil. These numbers on motor oil, 10W30, indicate its viscosity. The viscosity of a fluid is its resistance to flow. An example of a low viscosity liquid would be water. On the other hand, honey is a high viscosity liquid. The numbers on motor oil are the number of seconds it takes the oil to flow in a standard test. All these oil samples are 10W30, a multi-viscosity oil that's had a chemical called a viscosity index improver added to it to make the oil behave like a 10-weight oil in the wintertime and a 30-weight oil in the summer. This is one of the chemicals that the myth is worried about. This is the viscometer I built to measure the viscosity of oil in my experiment. You'll have to excuse the crudity of this instrument. I didn't have time to calibrate it to an official standard or to paint it. This viscometer uses an electric motor, this one's out of an old computer tape drive, to spin a metal cylinder inside a stationary cylinder. The gap between the cylinders is filled with the oil, and just as in your car engine, a higher viscosity oil will resist the rotation more than a low viscosity oil. The electronic control circuit keeps the cylinder rotating at a constant speed and measures the amount of torque required to maintain that speed. The higher the viscosity of the oil, the more torque required to spin the cylinder. This is the synthetic oil sample, and it's giving me a reading in my rather arbitrary units of 0.24. Now let's quickly measure the other oils. Well, that was interesting. They're all within 1 decimal place of each other, except for the synthetic oil, which is a little bit lower. So I guess it really is different. Even the cheap oil is right there with the others. Now, let's mix all the samples together and see what happens. I sure hope this turns out to be a myth so I can use this in my car. Well, there's no bubbling or smoking or anything. I have stirred this up well, and it's been sitting here for a few minutes, so let's test it. I'll use the same volume that I had in the individual tests, and we'll see what happens. The mixture reads 0.25. It's substantially the same as the individual tests. Myth busted.